హాయ్ హలో ఫ్రెండ్స్ అందరూ ఎలా ఉన్నారు? హాయ్ హలో ఫ్రెండ్స్. So today I am here with a beautiful presentation about thermal power plant or power plant funda. The basic cycles, coal-based power plant, combined cycle power plants, power plant systems, operations, all these things in a one presentation I am here. I will be explaining because all these power plant concept you cannot understand and I cannot keep in one video. So I will explain you step by step. Okay, today all the basic cycles, the four cycles of the power plant we are going to learn today. So are you ready for that? Okay, very good. So the basic cycles on which concept these power plants are working. What is the thermodynamic principle behind this to design these uh, uh, coal-based power plants, gas turbine power plants, okay, and combined cycle power plants, and how the entropy fixed, how the pressure and temperature maintained constant, what is the critical point up to which temperature we can go and where the turbine boiler or turbine can be tripped. So today we are going to learn the basic concept behind the power plant. So now we'll go for the Carnot cycle. What is this Carnot cycle? Carnot cycle is the basic ideal circuit. Okay, so here one is heat source is there. In another term, it is a boiler. Another is heat engine. It is turbine. Heat sink. It is condenser. So, and other than this, one more thing is there that is called our pump. Okay, so there are basic four items required: boiler, turbine, condenser, and pump. What is the purpose of pump? Here we have not mentioned pump, but in Rankine cycle there are four things. This is the open circuit. Carnot cycle is the open circuit. Okay, we are not using after the sink again this water again. It is not showing here to go into the heat source. Okay, here you can see here it is just normal curve. Okay, here S is entropy, here T is temperature, and this is the T S curve, and there is PV curve also is there. What is that? PV curve. Okay, friends. So basic idea is here we needs to heat the water with the constant pressure. Okay, and we have to convert the water into the superheated. So before superheated, the water must be saturated steam and then it will be superheated steam. So all those concepts here not mentioned. Carnot cycle is the basic idea what is happening. See friends, from here to here, okay, this is the pressure we are giving, feeding with the constant pressure. Okay, almost see here. Okay, constant pressure. We are increasing the temperature and then here what we are doing with the constant pressure heating is going on and the steam is converted into the saturated steam. One more point you should remember here, this is the critical point. Okay, this is the critical point of the boiler. So again this side of this curve, always remember it is turbine area, this is boiler area. Okay, and this portion also completely into the boiler portion, and this is the condenser portion Q2. Q2 is the heat sink. Q1 is the heat absorbed by the heat engine. Whatever the heat engine is here, this is the turbine. This is the work done. Okay. So shall we go for the real circuit? Okay, good. This is the Rankine cycle. So in the Rankine cycle, I told you the four major parts. One is boiler, turbine, condenser, and pump. This is combined complete circuit. Okay, so here Q1 is heat absorbed by the heat engine from the boiler, and Q2 is heat rejected by the heat engine to the condenser. W2 is mechanical work input to the pump, and W1 mechanical work output to the turbine. So friends, what is happening here? You see, if I put at this point number one, okay. So 1 to 2, what is happening? We are water. Water is heated at constant pressure P1 in the boiler until it is saturated. Okay, and from here 2 to 2 dash, it is superheated. Superheated means what? Superheated means high pressure, high temperature, superheated dry saturated steam. Here it will enters into the turbine. This blue line is the turbine portion. Okay, here what is happening? Here steam, saturated superheated steam enters here and it will drop to a lowest pressure and temperature condition. Here, this rejected steam goes into the condenser. The Q2 is the rejected heat. Okay, it is going into the condenser, and condenser we feed some cooling water from the cooling tower here, and it will be cooled out and it will be stored in the hot well under the condenser. From the hot well, one pump, that the name of that pump is CEP, condensate extraction pump. It will extract the DM water and it will feed into the boiler. Again, this circle will be continued. So how will calculate the efficiency of this Rankine cycle? The efficiency is whatever the output work done by whatever the input energy we are giving here. Okay, the input energy we are giving here is Q1. Okay, so output is W1 minus W2. Why we have to remove this W2? Because some energy we are using here for, for feeding the water into the boiler. Okay, so this is the exact actual cycle. Here some entropy will be dispersed. In the ideal circuit, there is the constant entropy, and in actual circuit, entropy will be little bit change. Next, we will go for Brayton cycle. What is the Brayton cycle? Brayton cycle, it is a gas turbine cycle. In the gas turbine cycle, here, the basic components are compressors, combustion chamber, and turbine. So here, in the compressor, the air will goes inside, pressurized air, and that will be compressed here. And that compressed air goes to the combustion chamber. And here, some fuel is coming, and that fuel burnt out, and that gas, the gas and this compressed air combines here, and that will goes into the gas turbine. This is the gas turbine. Okay, and this gas turbine is connected to the generator and the power will be generated here. And this Brayton cycle, it is only open cycle. Whatever the output coming from this turbine, it is normally goes to the HRSC, heat recovery steam generator, and that will comes in the combined cycle power plant. So what is the efficiency of the Brayton cycle? It is very minimum because here we are exposing it to the atmosphere, open cycle. Okay, so W2 is the input to the combustion chamber. Okay, and W1 is here the combustion chamber, the energy introduced or heat introduced in the combustion chamber. That heat is the input. Okay, so W is W1 minus W2. W1 is the output generated or output or mechanical output of the turbine minus the input, whatever the energy we are giving to the compressor, divided by Q1. Okay, next we will go for the combined cycle power plant. So if you see here, the combined cycle power plant, the efficiency is the sum of the output of the gas turbine plus sum of the output of the steam turbine. The both output divided by Q1. We are giving input here only. That input, okay, only the Q1 is our input and output is in two portion. W1 minus W2 is the output of the steam gas turbine and WT minus WP is the output of the steam turbine. Okay, so whatever the output or the rejected steam from the gas turbine, it is goes to the heat recovery steam generator and that heat absorbed here is QH. Okay, and that HRHG generates superheated steam. Okay, this is the steam generated here with the constant pressure and temperature will be the steam will be superheated or saturated steam. Again, it will be superheated, and that superheated steam enters into the turbine and it will be expanded. That is called isotropic expansion. And here the pressure and temperature will be dropped, and rejected steam goes to the condenser. And this is the condenser. Okay, same level. From the condenser, the water will be again lifted back with the feed water pump to the evaporator. Okay, and then it is goes to the boiler, and from the boiler again it will be as a saturated steam. It is a combined. Okay, this is the closed loop of the EM water. Okay, here it is taking outside air, and here we are feeding the gas, and there is a combustion chamber. Because of that combustion, steam will be generated, saturated steam. That saturated steam goes into the gas turbine, and that the rejection of this gas turbine again comes to this portion. Okay, HRSG. That heat will be recovered here, and it will be saturated again. That saturated steam again used in the steam turbine, and this will be recycled. So because of this, our combined cycle power plant gives highest efficiency than gas open type gas turbine. Okay, the actual curve you can see the entropy will be changed, because in ideal diagram entropy must be maintained constant. Okay, our always motto is to maintain entropy constant, but in actual condition it will be changes little bit. So friends, today we learned the basic ideal circuit of the thermal power plant, Rankine cycle of steam-based power plant, Breton cycle for the gas turbine power plant, and combined cycle for the both gas turbine and steam turbine combined power plants are there in India. Okay, for that purpose, we can improve the efficiency. We can reutilize the steam output. The steam comes out from the gas turbine in the HRHG, heat recovery steam generator, HRSG. Okay, and that HRSG generates superheated steam. That steam again enters into the steam turbine. Steam turbine expands as an isotropic expansion. There entropy is constant, temperature and pressure drops, and from the LP turbine it will goes to the condenser, and it will be cooled out with the cooling tower water, and it will be relifted back to the boiler. Okay, friends, if you want to continue these classes further, okay, kindly subscribe my channel Abhiram Vlogs, and press bell icon and activate all notification so that you will get next class. Okay, full based power plant simple circuit, and then we'll go for the reheater circuit, and then regeneration, and then combined cycle power plants. Okay, so all these things will be learned step by step. And power plant systems, what are the systems are available here, how to operate, how to start up the power plant, how to set down the power plant, all these things within one first class. Today we have completed second, third, fourth, fifth. In 5 classes I'll close, and I'll send you all these presentations so that you can understand very easily, and you can remember the concept forever in your mind. Friends, thank you so much.